The biggest problem is what's called the urban heat island. Haven't heard of the urban heat island, or you don't know what it is. If you have a car and there's a thermometer in your car, next time you're driving into a city or out of a city, have a look. You'll probably notice as you enter into the city that it gets warmer and warmer. Just, it may be a degree, maybe 2 degrees, a couple of degrees. Then when you leave, it gets colder again. That is called the urban heat island. Its cities are warmer than the surrounding countryside. Now, technically, that's human-caused climate change. We are causing climate change, but urban areas only account for 3 to 4% of the land area. And because there's more oceans, it's only like 1 to 2% of the total globe. So if you are using urban stations for sampling the temperature, you're not sampling the globe. You're just measuring urban climate change, not global climate change. And now that's urban climate change is important. Like since 2011, more than half of the world's population lives in urban areas. That's the UN estimate. They do these estimates of who lives in urban and rural, and looking at the population growth. Since 2011, they said more people live in urban than in rural areas, and people living in urban areas are indeed experiencing human-caused climate change, and like whatever you think about global temperatures, we can get onto that. But if you're living in an urban area, 100% I can say that the climate changes that you are experiencing are unusual. But like, if you're interested in global climate, then you have to get outside of the cities. Does that make sense?
Totally. Yeah, it does.
And this is just, I find this is from noaa.climate.gov, and it's a nice map. This is of Washington, D.C., and you could see the area here. You could see, I don't know if you can see, the green areas are cooler or whatever. And interestingly, if you look at the voting records for people living in Washington, D.C., they have consistently been voting for the party that says that we are seeing unusual climate change, which in your case is the Democrats, yeah? And so they are experiencing human climate change more than outside of DC, which is what they're seeing, urban climate. And so here's a problem for our global temperatures. If you have a weather station that when it was set up, it wasn't so urbanized. By the time it becomes urbanized, its record will show the natural climate change from outside, but it'll also show this extra little bit of warming that comes from the urban area. And this is very difficult to calculate, but this is looking at the NOAA's Global Historical Climatology Network, version 3, which is their older one, their older data set. But it's the one that we did most of our analysis on. And so they included in it estimates of both the night brightness associated with each station and the population density with each station. So for version 3, they dropped that. They said, oh, we don't need to worry about urbanization, which was a mistake in our opinion. And so we're working on trying to analyze their version 4 stations. Now, that's ongoing work. We can talk about that later. But you can see here, first thing, this is looking at the number of stations available for 1880 to 1910. So for 30 years, and these are the stations that have the data for that 30-year period at the end of the 19th century, early 20th century. So the first thing you might notice is there's very few in the Southern Hemisphere. Am I right? Does that seem? Yeah. Now, modern era, we've lots of stations in the Southern Hemisphere. Yeah. But if you want to look at temperature change since the 19th century, you're mostly looking at the northern hemisphere. And we've been pointing that out. We're saying we haven't been able to comment on the long-term trends in the southern hemisphere because of this problem. And so we keep on saying we're in our papers, when we're looking at the northern hemisphere, we're looking at the northern hemisphere. And then you'll get people saying, well, these group are looking at the global temperatures. They must be better. It's like, yeah, okay. They can say they're looking at the globe, but does that mean that they're actually looking at the globe? So the other point is that most of our longest and best kept stations are urban. Now, they weren't urban in 1880 as they are now. That's the point. If you want to look at the temperature trends from continuous, I'll just show this in another way. This is the stations available in 1850. And we're looking at how urbanized they are now. The same stations. Only 5% of the stations are still rural. The stations that were available in 1850, 71% of them are now highly urbanized. And you get others that are partially urbanized. Another problem, and this is another controversial one, that some of your listeners, I imagine, will be saying, no, this is dreadful. And then others will be saying, no, this is perfectly good. So this is called the temperature homogenization. And so a lot of the groups, they recognize that there are non-climatic biases in the temperature records. Well, since like the early 2000s, even like late 90s to early 2000s, groups started developing statistical homogenization computer programs, computer algorithms. So currently, NOAA use Mene and Williams pairwise homogenization algorithm that was developed in 2009. But there are other similar, we've written a couple of papers on this. The idea is what they will do is they will take each station record, weather station record, and they will compare it to the weather stations from nearby neighboring stations, year by year or month by month. And they'll say, oh, this one's going up, this is going down. And by doing this statistical comparison, they will apply adjustments to each station up and down at different points. And they say that those adjustments are correcting for non-climatic biases. And the problem is, what you end up with is a homogeneous mix. So homogenization works. If you take homogenized milk, I don't know if people are familiar with the word homogenized, but that's what they're doing. They are bringing everything to show similar trends. So in 2022, we did this collaboration with a lot of European scientists, some of them from the meteorological groups. And by the way, this is a collaboration with different people. And I need to stress that a lot of these scientists, they agree with homogenization. They agree with the IPCC. They don't necessarily endorse all of the views that I have or my colleagues will have. But that's the point of when you're doing good science, you don't have to agree with your co-authors on everything. But we agreed with everything that was said in this paper. Okay. And that's the key bit. All of the co-authors agreed to what we found. And what we found is we took NOAA's homogenization adjustments that they had applied to each temperature station that we had. Each of these groups had looked in the documentation for what are called station history metadata. So that's where the station observers would said, we had to move our weather station because there was a building was about to be put up around it. And so they said, so we've moved it 100 meters here, or we've changed the old screen was out of date. We've replaced it with a new one. We've replaced this. So they have recorded, a lot of these observers have recorded major changes that took place at different times of the record. And we said, okay, can we get that? And we had it for more than 800 weather stations from 24 European countries. I don't know, can you see all of the red dots? They're the stations that we got weather station, the station history metadata from observers from them. And the wide ones we didn't. So we just analyzed the 800. What we noticed is, just as our colleague Peter O'Neill, he's a retired engineer, and he downloaded NOAA's homogenized data set, I think by 2011. It was the first time he downloaded it, or maybe 2010. You can check the paper, but he started. He went back to check the adjustments that had been done to a weather station, and he realized that the adjustments had changed. And a few months later, then he went back and he said, okay, and then he realized that every day NOAA recompile the adjustments for the station records. And every day, those adjustments are different for a lot of the stations. And they shouldn't be. If they're correcting for, like, say, oh, there's a warming bias of plus 0.5 degrees in February 1957. Okay, that's great. But then the next day, they rerun it and said, actually, it's a cooling bias today. Well, it shouldn't be. So what we did is we said, let's just check, first of all, how consistent are the adjustments? And what we found is only 17% of their adjustments remain consistent from day to day. For a given, you download the homogenized record, and only 17% of the time does that stay the same. Each time you download it, it'll be different. And then we said, well, how many of those adjustments actually correspond to a documented station history event? 19%. Okay, so does that make sense? Well, do you get what we're trying to say? We were shocked, and I can tell you, all of our co-authors were shocked, and I said that they all agreed with the IPCC and all of that. Quite a few of them said to me, we might have to look at some of our assumptions again, but I don't want to put words in their mouths. We did this other paper. This is last year. Was published in an AMS journal, JAMC, and it's called Evidence of Urban Blending and Homogenized Temperature Records in Japan and in the US. I don't want to get too long because I know we're talking on for quite a bit. I know we've quite a bit to go. But this is basically what we found is, do you remember is saying that it homogenizes, the algorithm homogenizes. What we found is that it's like if you have strawberries and bananas and you put them into a blender and you blend them, at the end you get a nice strawberry banana smoothie, and it can be nice. But what you don't get is pure strawberries or pure bananas. You get an average of the two of them. That's what happens. If you put urban station records and rural station records into their homogenization blender, what you get at the end is the urban records go down a little bit. That's fine. You can remove some of the urban, but the rural goes up. And then here's the genius that a lot of people don't have came up with. They said, oh, now let's compare the difference between the rural homogenized and the urban homogenized. And then it's like, wow, most of the differences are gone now. And it's like, wow, the blending seems to have worked. And that's a problem that we've been telling people about for that is not correct. So we've been telling about this for more than a decade now. But we just said, look, can we go and do it? So this was starting in 2015, and our last update was in 2019. Or we did it in 2021. But they remember the GHCN version 3, it was discontinued in 2019. So we can only do it up to middle of 2019. So we can only go up to 2018. And what we did is we said, can we identify regions where we can have information about the stations and only use the rural stations, or stations where we can correct for urbanization bias, or we had station history information. And these are the 4 regions. So how does it compare? This is the Northern Hemisphere using all stations. You can see it going up here, right? This is our estimate using only only the rural stations for those regions. Now, we did analysis as well. We do a comparison in the paper where we compare the urban and rural for those 4 regions. We do all of this stuff. We compare to others. So can you see the differences? Now, for me, these are very different. But I just go to do, okay, what we're finding here is you could see warming, a very slight cooling from the 40s to the 70s, but then continuing going on. Not really much of a change. What we find here is warming from the end of the 19th century, which was, as you know, the end of the Little Ice Age, up to the 1940s, and then cooling from the 40s to the 70s, which maybe some of your older listeners might be familiar with. I was born after this cooling, but there was a global cooling scare in the 60s and 70s where people were noticing the temperatures were cooling. Then they started warming again, and everyone said, oh, we'll change our mind about that. But what we're finding here is, yes, it's warmer than the end of the 19th century, the Little Ice Age, is warmer than the 1970s, the end of the global cooling period. But it's not this continuous rise that you see with the urban and rural. It's more cyclical. You have a rise, fall, rise. Does that difference make sense? Now, look, it's not a perfect analysis. It's the best we have. None of the other groups are doing a rural land using unhomogenized data. None of the other groups are doing that, using unhomogenized data, without using this blended data. All of the groups are either using the blending or they're doing, and so this is the best estimate of Northern Hemisphere rural land temperatures that's out there. We have here, that's our rural record. Here's, again, Northern Hemisphere. Now, this is the sea surface temperatures. And they're not that different. Like, are they? You're seeing similar. You have the cooling, warming, cooling, warming. The magnitudes are different, but like, they don't look too different to you. Tom, what do you think?
I agree. They look kind of the same.
Yeah. And interestingly, here's tree ring proxies for the Northern Hemisphere. And again, you find you don't get the cooling at the start, but you do get the warming. Peaks a little bit later, more like the 50s instead of the 40s, then cooling and warm. So, and it finishes in 2000. Glacier lands, you're getting similar patterns occurring. And again, even weather balloons, the problem with the weather balloons is we only really have data from about 1958 that we have global coverage, and the satellites only from 1978. So yeah, we're saying this rural record is consistent with the tree rings, sea surface temperatures, glacier lands, qualitatively, weather balloons, satellite, ocean heat content. the IPCC. They said no recent literature has emerged to alter the AR5 finding that it is unlikely that any uncorrected effects from urbanization have raised global land surface air temperature trends by more than 10%. And therefore, we don't need to worry about it. Now, I actually argue 10% you should be paying attention to. And also, notice that it's not a linear trend. What we're finding is in the rural data is showing more of a cyclical. Just a quick thing of what's next. So this is what at series, some of the projects that we're working on now. So just to say that our Dutch rural record, it was based on version 3. For version 4, no one decided they didn't care how urban they were. They abandoned that. So we're working on developing a new data, but we've also shown that you can't rely on this homogenization. So we're looking at collecting station histories as well and metadata.
One major one is there any sort of dynamic as you dig into this more and more that the more we learn, the more you find out that everything is more complicated than you thought it was? Is there anything about that? Or
100%. 100%. And actually, let me see if I can find this nice quote. John Wheeler, who's an American physicist, he said, "We live on an island surrounded by a sea of ignorance. As our island of knowledge grows, so does the shore of our ignorance." And I think he was correct on that. Does that make sense?
it does.
Very
Yeah.
good.